Hi to everyone. The Youyeetoo X1 is a single board computer based on the x86 architecture, launched by Youyeetoo Tech Company, capable of running the full-featured versions of Windows and Linux, possessing the characteristics of low cost and high performance. Have you heard of user-driven and kernel-driven drivers? What are the differences between them? Why do we sometimes need to create kernel drivers? Today, we will take the Youyeetoo X1 as an example, introducing you to the concepts of user drivers and kernel drivers, and we will guide you step by step to write a kernel driver for an OLED display. User drivers operate in user space. The operating system kernel provides API interfaces for it to call. They are relatively simple. They do not require direct interaction with hardware. Kernel drivers, on the other hand, run in kernel space, interact directly with hardware, possess higher privileges, and real-time capabilities. User drivers are generally used for interaction between application layer programs and hardware. Kernel drivers are responsible for managing the deep communication between the system and hardware. Sometimes, user drivers cannot meet the demands for direct hardware control or performance. This is when kernel drivers are needed. For example, in scenarios with high real-time requirements, operations in user space can sometimes be delayed. This could potentially impact the system's stability or performance. Kernel drivers communicate directly with hardware. Kernel drivers can effectively reduce latency. Now, let's move on to the practical operation phase. We will start by creating a kernel module. First, we write the initialization function of the driver. Next, we will implement control over the I2C bus and interact with the OLED display through this bus for data exchange. Once the driver is loaded, we can check the initialization results through the kernel logs and successfully display data on the OLED screen.